to do is to flash, of course, the latest image there, and then in the settings, in security right there, you set this developer mode on. That allows you to use plenty of tools to see that what is happening in your device, what kind of a function, what kind of a system calls, what is the memory usage, what is the stack usage, what is the heap usage, what is the energy usage, and so on. That's one thing, and then it allows easy debugging with your device, with your PC. I don't have a connection now. I'm expected to use, or I'm going to use the USB cable, and you can see that there is a SDK connectivity tool here. So now it can't be easier in Nokia world than this. Just launch the SDK connectivity tool, and then it asks you what kind of a connection to use. And now IP address is not very valid because I don't have a USB connection. But that's all what you need to do. And then I can install applications to the phone. So start SDK connectivity, select the USB, and now I have some valid IP address over USB. So you don't have to configure anything. It all takes place automatically for you. Then the basic development tool is, surprise, surprise, Qt Creator. You can't get rid of this. And before we start any of our projects, you make the connection settings in tools, options. You can use the emulator. Emulator is using the Linux tool QEMU to emulate the binary, the ARM binary of this device. It's very similar. Even the drivers are very similar to the real phone, and it's extremely slow. So in my opinion, it's right now, I don't know, I have only 3 gigabytes of memory in this computer, whether it's the memory or what, but it's useless. You won't use that, it's so slow. So really, if you seriously start development, you need the device. And in the device configuration, this is the important thing. This was 0.0.0 and so on. But now, when there is a real connection, I can read here that it's 192 and so on, the same address which is already there. And then I can define the password. This password is not good because every time a connection is lost, you have to re-enter the password, and typically changes, or actually changes come along. So in the normal case, you define a key. You create, there is a tool what you use to create a key pair, and then you install the key into the device, and you use these to create a debug session to the phone. Okay, I will use password anyway now. That's what I prepared. And the password is given by this SDK connectivity tool. And then of course you test that the connection works, and you can see that what kind of Qt libraries have been installed to the phone, or Qt packages, if we are accurate. That's it. You can create a default project using the wizard. If you use the latest Qt SDK, the Harmattan target is there as well. And that target also includes the plugin to implement this wizard. Harmattan application. Oh yeah, it's the good name, not always the hello world. You can use the remote compiler if you want. So Nokia developer has the server where the software will be compiled. We don't need that functionality right now. There is a default application, doesn't match the criteria what we have for the Miko icon, but we can use that anyway when we start the development. Create it. Okay, it asks that if you want to add several Debian packaging files into the project, and yes, why not? There you go. And your project looks like this. Takes a while as it finds the files. So Qt is familiar to you. I don't worry about the Qt, but if you look at Qt so much that we understand how this QML is working, what is this declarative view? What kind of a Qt class? Obviously it's a widget because we call show for that, but what kind of a widget? Yes. So QDeclarative view has been derived from the graphics view. Everything what you run in the graphics view. What is now programmed with my paths that it doesn't find my graphics view. And then the easiest way is to define the main QML file from which the interpretation of the application starts. And you can create dynamically additional components. You can load both in C++, you can load in QML new components, meaning that those are additional QML files. Okay, and then we have two files. We have main QML and main page QML, which are then packaged inside the resource file. So this is how we deploy in this application the QML files. It's easy to handle. The application doesn't have to worry where these QML files are located. So easy way to distribute, deploy them inside the resource files. Okay, let's build it. So if you look at a little bit here, the build settings, you can see that there are two kinds of APIs that I can use. I can build for the Miko Harmattan or just for the Harmattan platform API. So if you build applications using Qt, using QML, you use the Miko Harmattan. If you build, let's say, a server, C++ server which is running in Miko device, you use the Harmattan APIs. Or if you use anything in the API, if you use, for example, the tracker at the low level, not using the Qt APIs and QML bindings to that, or mobility bindings, then you use these Harmattan platform APIs. I have two targets. I have N950, which used to be the early access program, developer program, SDK, and that is not distributed anymore. Now you only have a Qt SDK, and that's the one what I'm going to use as well. So that's why I have actually two selections left, either debug or release. Let's make the Harmattan API Qt SDK debug build. you can see that when I have a new project, by default, the device to deploy will be the emulator. I can start the emulator by pressing this additional button. The button appears when I select that I will have the Harmattan target. I won't even demonstrate that to you. You may play with this SDK if you haven't played that and see how many hours it takes in your laptop or in your desktop. Okay, perhaps not so long. So let's select the device to deploy to be the real Harmattan device what I have there. And now we should have all the basic settings set. There will be plenty of warnings. For example, this dash Unix is deprecated. That comes from the Mac tools. And most of these you just ignore. Because there will be some nasty ones that you really can't change. Okay, complaining about the QString.h. Okay, building, then it's linking here. And you can see that after linking, I didn't do anything, but it will create the settings for the default Debian package for me. So it doesn't matter, emulator deployment and device deployment take place in the same way. In both cases, you create the Debian package, and the actual package will be then copied to the phone and installed there. Okay, package created. As you can see, then it starts installing the package. Now it's installing that in the device. What is AE? Okay, you couldn't see it. AEGIS installing. What is this? Have you ever run into this? That's related to the security framework. We define that what kind of capabilities or access rights the application has, or what it requires from others. I will show it to you soon. Okay, deployment finished. And then you can see that now it starts a remote process, which is the application. And then here you can't see much. There is one button what you can click and the application is running there. Not very interesting at this point yet. Okay, so what has changed? There is the Harmattan target. You don't have to do any kind of an integration work. If you install this SDK to Windows, there will be an error that the USB driver is not found. Just ignore, and you can find the USB driver later. You can install the USB driver from the Qt SDK. MUD USB driver. There is the driver for Windows. In other platforms, this problem don't occur. But otherwise, it's just making any other kind of a project for Symbian or whatever you have made with the Qt Creator. You don't have to set any paths, anything unless you use something extra. If you want to use additional Qt libraries or any other libraries, of course, those have to be known by the tool, and well, that's it. So if you have problems with the paths, use the include path, and then the library path variables in the project file to define the location of any additional stuff what you have. This is a hack. How do you normally handle extra things what you add? Extra things. Let's say Qt Mobility APIs. How do you handle Qt Mobility APIs? You can actually see it here. What I'm talking about. So typically if you add something additional, you should define features. Project features, declarative is one of those features, location could be another feature, and so on. And related to these features, there is the project feature file, and there you define where are the headers, where are the source code, or where is the source code, where to put the library files if you create libraries, where to put the EXEs, where to put the DLLs, and so on. That is the right way. Some of you asked this in the morning, so that's why I show it. I will show from the desktop. So in all of these targets, they have their own Qt folders, and in the Qt root there is makespecs. Makespecs is used to define what is the target and what is the compiler. We use the HP Unix with the C++ compiler, or we use Linux with 32-bit Linux with C++ compiler. This is where you define all the platforms and compilers what we have, and then here is the features as well. And then the features, you have this PRF, project feature files, where you define additional paths. This QWT is one what I have recently added. And here you then define that what are the additions to the include and library paths. And then it works. This is something you asked in the morning. You have these red underlines. So the project file, PRO file, the include path, and then the library path. Or to do it right, in a better way, define those in the project feature file. What is QWT? Has anyone of you used this? This is used to paint graphs. You want to have two-dimensional pie charts or just scene curve or whatever. You can use this, and there is also a 3D version, but that's the difference. So this is what we have in that tool. 4.7.3 of the Qt version, Qt Quick 1.0. Notice that Harmattan use is actually 1.1. If you try to use QML elements with 1.0, they won't work. They require 1.1. Mobility APIs 1.1.3. Okay, again, these mobility APIs, there have been something which hasn't worked, which is now started working. So that's why the version information is important, to be able to check that. Can you expect this feature to work or not? Multimedia has been problematic, now it works. No problem. Location APIs have been problematic, at least. Qt Creator 2.2.1, there the new feature is the QML Designer. So now you can't only drag and drop Qt widgets, but you can drag and drop Qt elements. Harmattan emulator, which was slow. Integrated cross-compiler, so that we can build for the Linux and ARM targets. In Symbian, for example. Simulator is a desktop tool. You make a desktop build, but allows you to use the mobility APIs. So you can test the location, you can test the sensors and whatever, see that you have proper values. And then the package support as well. So everything what you expect. But then, plenty of more. Okay, this tells you to do the same things what I told you when I started this session, to put the developer mode on. And there are plenty of additional tools what you can use. Some in the command prompt and some of these in the graphical UI. Okay? LA trace traces the library calls whatever programs what you execute make. You can check that how frequently or what libraries will be called. System trace is a little bit similar, but shows you the system calls. May be useful, for example, to see that how the file system, when it uses the Linux kernel file APIs, how the file system will be accessed. If there is any bottleneck related to that. So these are just standard Linux tools. These are not any Harmattan related. Valgrind is the familiar Linux tool to detect and locate memory leaks. It can also show you the heap profiling, so how many allocated cells, how many free cells, what is the size of the largest free block, and so on you have in the heap. Also the cache can be profiled in the same way. How many cache hits, how many cache misses, how many flushes, and so on. And then you can create a call graph so you can profile the whole execution of your program. So this function was executed this and this many times, this function was executed never. So you can see that if there's any obsolete code, or you can try to find bottlenecks in your application. Then we have HTOP, the process viewer. I could actually demonstrate. So shows you that what kind of Linux processes are running there, with what kind of a process identifier, with what kind of a priorities, the nice values, what kind of a CPU memory usage they have, and so on. So this may be useful to quickly check that how your program is executed, what kind of a load it causes to the device, how much memory, how much swapping will be used. But then perhaps a little bit nicer user interface is provided by the energy profiler. So the idea is that you start profiling, do something, then you launch an application, gallery for example, do something in the gallery. This is my dog, for example, and then go back to the energy profiler. I was wondering that where that is. And then you can see that what is the power, what has been used, current, voltage, how much memory, what kind of a memory usage changes, were there, how the CPU load changes when I started the gallery application, what are the network functionality. Now it should be quite surprising if I have any received or transmitted bytes because I don't have the network connection, that the applications may still send, okay, not any received packages and send packages and so on. And then no, my fingers are too thick. No, I didn't spike it. So for example this. This is funny small thing what you can get there, that after or during this profiling period, how much the backlight has been on and off. And now you may wonder that what the hell, is this important information or not? Okay, depends on your application. Of course, the application shouldn't keep the lights on forever. And actually, this is a requirement. So if you look at the requirements that how to publish your application in the Office Store, there is a test that your application will switch off the lights if it's running in the background long enough. Shouldn't keep them on. So that's why, for example, this kind of a test, or using the profiler to make this kind of a test automatically, is useful. Although it's small thing there. But really, Qt Creator tries to make some updates. You need these tools not only, of course, to check that your program behaves in the as good way as possible, but really in the Office Store publishing requirements, it will be required that you don't have memory leaks. You allow other programs to behave normally, so that, for example, your application doesn't alone use all the CPU time. Phone calls can be handled in the normal way. Your battery usage is as small as possible. That's of course may be difficult to solve. So there, of course, you can optimize it yourself. See that, okay, now it uses this much, and if I say the code, change the code, it will use this much. So that's why these tools are very useful and actually rather important from the publishing point of view as well.